Today we're digging into a paper with a title that just grabs you: The Unbearable Slowness of Being. It gets right to the heart of a question you've probably never even thought to ask about yourself. And it starts with a comparison that is, well, it's pretty humbling. Think about this. You probably get annoyed, right, when your Wi-Fi drops below, say, 100 megabits a second. It feels sluggish. But what if I told you that your conscious brain, the very part of you that's processing my voice right now, operates at around 10 bits per second? Not megabits, not kilobits, just 10 bits. It just doesn't seem to add up, does it? We have these incredibly powerful, complex brains inside our heads. So how on earth can we be so fundamentally slow? How is that even possible? To figure this out, we have to start with the evidence. Where does this number even come from? Let's look at what the source material calls the 10-bit per second rule. Okay, first, take an expert typist. They might hit 120 words per minute. Now, you can't just count the letters because language is predictable, right? You know a Q is almost always going to be followed by a U. So when you calculate the actual new information being conveyed, the rate comes out to, you guessed it, about 10 bits per second. But you might be thinking, okay, that's typing, that's physical. So what about something that's pure perception? Well, look at a world record blindfolded Rubik's Cube solver. It's an incredible feat. They look at the cube, memorize its state, and then solve it completely blind. And the rate at which they absorb that crucial information, it's 11.8 bits per second. It's practically the same number. And get this, even you, listening to me right now, fit the pattern. The sweet spot for understanding spoken English clocks in at around 13 bits per second. So from your fingers to your eyes to your ears, these totally different activities all slam into the same invisible wall, a cognitive speed limit that is just remarkably consistent. So if our conscious output is just this tiny trickle, what about our input? This is where things get really wild. This brings us to what the paper calls the great brain bottleneck. Just look at the insane difference here. That giant bar, that's your eye, just one of your senses, pulling in data at a staggering 1 gigabit per second, a billion bits. And the amount you actually consciously process and use, that tiny little sliver over there, it's so small it barely even shows up on the chart, just 10 bits. This isn't just a gap. It's a cosmic abyss. The paper even gives this a name, the sifting number. It's the ratio of everything coming into your senses versus what you consciously process. And it's about 100 million to 1. The authors have this great analogy for it. It's like trying to get a sip of water from the Hoover Dam. Almost everything just rushes right past you. So how does the brain even handle this? Well, it seems to run a two-part system. You've got the outer brain. That's your sensory system, and it's like a parallel supercomputer, processing all those gigabits at once. But then there's the inner brain, your conscious thought, and it's more like a slow, old-school calculator that can only do one thing at a time. This handoff between the two systems is where the bottleneck is created. This leads us to the big investigation. If our inner brain is this slow, why? It's time to line up the prime suspects. But first, let's get a common objection out of the way. A false lead, if you will. What about people with so-called photographic memories? Couldn't they break this speed limit? Well, the paper is pretty blunt about this. Turns out, true eidetic or photographic memory has really weak scientific support. I mean, if it were real, you'd expect world memory champions to blow this out of the water. But they still operate at, you guessed it, around 10 bits per second. Even these unbelievable feats of memory, when you actually measure the information rate, fall right back into that same range. So photographic memory, it's not our answer. So let's move on to our first real suspect. Could it be that our conscious mind is just a one-way street? Are we fundamentally stuck in serial? I mean, think about it. You can really only follow one train of thought at a time. And the famous cocktail party effect, our ability to tune into one voice in a crowded room? The paper argues that's not a feature, it's a bug. The real question is, why can't we follow all the conversations at once? Even chess grandmasters don't think in parallel. They analyze moves one by one, sequentially. This leads us to suspect number 2, which is an evolutionary one. Is it possible we're just running on ancient software? Is this slowness a kind of hangover from our deep past?
The argument is pretty compelling. The brain's original job wasn't to write poetry or do calculus. Its primary purpose was much simpler: control the movement of one body in one physical space. The whole architecture was built for basic tasks, like following a scent trail. So our incredible capacity for abstract thought? It's basically a hack, a fancy new program running on old hardware that was designed for a much simpler, single-task job. We inherited its slowness.
Okay, so we're slow, we're serial, our inner brain is a bottleneck. Why does any of this matter? Well, it turns out that understanding this cognitive speed limit completely changes how we should be thinking about technology and our future with it. This quote from Elon Musk about Neuralink captures a feeling I think we all have sometimes. This idea that our thoughts are incredibly rich and fast, but we're trapped by the slow bandwidth of our fingers on a keyboard. We feel like we think faster than we can speak or type. But here is the absolute bombshell from this paper. The bottleneck isn't our fingers, it's not our mouths. The bottleneck is the inner brain itself. This means even a direct brain-computer interface wouldn't unleash some fire hose of thought. It would still be capped by that fundamental cognitive limit of about 10 bits per second. And this theory perfectly explains why some technologies have struggled while others have succeeded. Retinal implants that try to just dump raw data into the brain, they haven't worked well because they're fighting the bottleneck. But you know what does work? BCIs like speech decoders because they work with the brain's naturally slow serial output. It shows we only need to move a few bits per second for really complex stuff. And you know what? Our voice is already a pretty amazing interface for doing just that. All of this brings us back to a really profound mystery, what the authors call the unsolved inner world. When you boil it all down, it's like our brain is two completely different machines fused together. You have the outer brain, a fast, parallel supercomputer swimming in high-dimensional sensory data. And then you have the inner brain, a slow, serial, low-dimensional machine for conscious thought. Two different worlds, somehow working together. And that leaves us with this final, absolutely mind-bending question. If our conscious thought, our inner monologue, everything we experience as us, is just this one slow 10-bit per second stream, what are the other 86 billion neurons in our skull actually doing all day? And that right there, that might be one of the biggest unanswered questions in all of science.